I'm going to find China. China, you ready? Yes. Also, some support for you from your team. Just wait for the people to come in, and then I'll give the microphone to you, and you can use this for the presentation. And just be sure that you speak into the microphone. Yes? Okay. Good luck.
Thank you. Hi everyone, I'm Chen Lu from TrueSense, and our topic is Sense Life with Color. So let's talk about our team. Our team is made up of 12 bachelor students, and we are coming from biological science and biomedical engineering. It's our photos, and it's our first time to be here to join the SensUs. It's exciting and challenging as well. And during the whole processing, and we have learned a lot from this biosensor, and also during this week, we have learned a lot from other teams, and their ideas also give us a lot of inspiration. And here, I'm going to present our ideas of our biosensor. It's like antibiotics abuse is very common in China, and we hope that we can apply antibiotic detection in our daily life, create an antibiotic-free environment. I mean, not in the it's not exactly free, but to reduce the overuse of antibiotic is very important. So we hope that we can develop a biosensor that is convenient and easy to use, and it won't cost that much, and also it's environmental friendly. And when we protect our own health, we are also going to protect our environment. So our biosensor is mainly based on the strips, and we use the antibody and antigen reactions to have the color reaction, and after imaging and data analysis, we can get the result from it. So this is our core part, is the strip itself, and we use immunochromatography to apply the whole immunoreaction. And then it's the basic reaction that's just following the fluids, and the traditional immunoreaction are separated in different locations of the strip so that color reaction can be detected. And in the future, that we hope that we can integrate the imaging processing and the data analysis together and use a mobile phone to get what we want. And also, we hope that these strips can be designed more convenient for use. Like we don't have to get too much preparation for the sample, and so that we can detect vancomycin at any place and any time. Besides, our biosensor can detect more than the blood plasma itself. Other environmental fluids can also be used for the detection. And thank you. And thank you.
Thank you very much. Are there any questions for Team China? You can ask them now. There is some time, but you can also save them for the market. Yes, I'll give you the microphone, please.
Thank you. How did you come to this idea to use chromatography?
It's because that at first we hope like to apply the ELISA is the most traditional way, and we think that like how to use like separated how like using ELISA wisely, and so as you can separate the immunoreaction between antigen and the primary antibody, and the primary antibody and secondary antibody. But also like they have the strips for the pregnancy test before. So I think, yeah, maybe we can use that one, like to apply it to the vancomycin detection and something like that. Yeah.
And any other questions, maybe?
Yeah. When the competition is finished, would you as a team like to continue to develop your biosensor into a real life product?
Of course we will, and like we have like learn some ideas from other teams, and we are going to improve our data analysis. And also, we hope that we can find some help from the computer science students to integrate all the data imaging and data analysis together. Yeah, thank you.
Any other questions? Maybe there's still some time. No, that's it.
Thank you.
Okay, thank you very much. And then we're going to the next team. So I hope you'll stay to support them as well. And hopefully they're over there. Yes, they are. It's the turn for Denmark. So please. Hi. Okay, I think that's it from your team. Yes? Okay, then the microphone is yours. Good luck.
Thank you.
And this one.
Oh yes. Oh my God. So many things. Yes. Welcome. The more the merrier. Right. Hello, everyone, and thank you for coming. My name is Emily, and I represent Detectors, the census team from the Technical University of Denmark. We're the ones with the national anthem printed on our PCB here. You can come see it afterwards if you want. We can also sing it for you if that's necessary. So this year we visited the University Hospital of Denmark, Copenhagen, and as a part of our field study. And we realized just how busy the staff at hospitals are. And we were wondering, what if we could make a device that could make their lives just a little bit easier? Well, ladies and gentlemen, we already have. You're welcome. With this little device, I don't have enough hands, sorry. This little sensor here efficiently cuts down the waiting time that each doctor has to spend on each patient from hours and hours to mere minutes, because waiting time is a waste of time, especially in hospitals. And so, the technology behind it is simple. You put a drop of blood plasma here and connect this part to an electrical measuring device, and within a few minutes, it gives you the exact concentration of vancomycin in the blood plasma. But this isn't even everything. Oh, sorry. Yeah. With this sensor, we contribute to the United Nations Sustainable Development Goal number 3 by good health and well-being, because we ensure safer treatment for each patient faster, because by decreasing the waiting time, we increase patient safety. And this isn't even everything, because we also contribute to the Sustainable Development Goal number 12, responsible consumption and production, in the future, we imagine at least, because we see a future where we can use this device in a lot of other applications as well. We see an application in the farming industry, for example, where we can ensure that resistant bacteria won't spread among species, for example, between pigs and cows, due to the antibiotics that is in their food. And by doing this, we also hope to reduce the aforementioned workload in the hospitals, because people will not get ill from the resistant bacteria. So antibiotics resistance is very real, as you can tell. And it sounds overly dramatic, but it is the truth. It's a matter of life and death, and this sensor can save lives. Thank you. Questions? Yes?
We'll hand over the microphone because, or you can
I can
also
just repeat.
repeat the question.
Yeah.
Yes? Okay, great. Thank you.
Yes.
What are the main challenges you have faced?
The main challenges. In which category? We have many challenges. I'm a part of the management team of the group, and the challenges that we're facing is a need for more market insight, more contact, more direct contact to the hospitals. We did interview a senior physician at the hospital in Denmark, but we would probably need to do more field studies, more research in that point, and also have obviously exact actual contracts with hospitals to actually ensure that they will use our device. And then, of course, manufacture the biosensor itself. Do you want more the technical?
So, can I get the question again? What are the challenges for the technical aspects? Well, we are currently optimizing our chip in many different aspects. So we're making the binding assay on the surface of the chip even more precise, so we can detect vancomycin concentration with a lower margin. And there's a lot of optimization steps during different processes. And the more we can incorporate on the chip, the easier it's going to be used for the hospital sector.
Other questions? How much time do we have left? We can still sing the national anthem.
If there are not any questions from the public, maybe I have a question because we just got the question for the other team. If you're going to continue with your project after this competition, and actually I'm really curious if you're doing that as well.
Good question. So whether or not we're going to continue with the project, and yes, we are. We have a patent filed, pending so far, and we hope to continue to develop a startup company during this fall in the next year or so.
With the same team?
With the same team, more or less, depending on how many people actually have time in the end. But we will see when we get like actual consistent results with the sensor. Yeah, very nice.
Maybe some questions, or then this is
Thank you.
Yes, thank you. So we're actually like up before schedule, so I didn't think that was possible, but I would like to invite the USA. I'm going to get the next team. You're ready? Yeah. If you're a little bit early, but if you're ready, we can start. That's okay.
Yeah, I mean, I would like to wait because like my mom might be tuning in, so I want to wait till like, it
Okay.
starts.
Oh, yeah, sure. Yeah, it's probably, I think it's in 2 minutes or something. So
Yeah.
no, of course.
Dame, het is goed als je het voorloopt, want dan kunnen wij alle pitches goed opnemen.
Oké, maar zij wil wel even precies tot 12 wachten, omdat haar moeder dan
Online kijkt.
online kijkt. Ja.
Oké. Ja, dan moet ik hem eens inqueuen nu.
Oh ja, sorry. Okay, so we're just waiting a few minutes to get on schedule because all the parents and family are also watching online in America, which is actually really cool. And I hope you already voted via SensUs Digital. Or if you did not, please do so. Because I think it's up to 3 o'clock that the votes can maybe, you know that? Yeah, so you can vote until 3 o'clock. And then I hope that America is ready because I don't have that many good stories. Yes, please come in. Yes, you're ready? Yes, I'll give you this one.
Oh,
It's
perfect.
yours?
And then this. Okay.
Yes.
Awesome.
Good luck.
Thank you. Hi, I'm Sydney Florianzia with the U.S. team SensNC from the North Carolina State University. We're a multidisciplinary team. We've got chemical engineers, electrical engineers, material science engineers, biomedical engineers, marketing, and design, all working together on this project. So y'all ready to see the future? All right. So this is our device with our very clever acronym, molecularly imprinted polymer, therapeutic interdigitated electrode. And y'all will see how all of those words come into play in just a few. So I explained who we were and everything. So vancomycin is difficult to detect. We know this. Our solution is to use a molecularly imprinted polymer sort of as a lock and key type system, right? So just like antibodies attached to their target molecule, we have designed this MIP to fit vancomycin and vancomycin alone. As you can see here, we build the polymer around the molecule template and then elute it off, leaving these holes that once a sample of vancomycin, once a plasma sample containing vancomycin comes in, then the vancomycin can fill these holes. I'm going to go through that step by step. So, high level, we first take a sample of human plasma and we drop it onto this interdigitated gold electrode that has an array right here. So this circle has a molecularly imprinted polymer, or MIP, on it. We then place this chip into our device, which uses electrochemical impedance spectroscopy to measure the impedance change. The specialty of our device lies in the chemistry on the chip, in that polymer. So we integrate a peptide that is specific to vancomycin into our MIP. So the MIP provides the loose structure that the vancomycin will fill, while the peptide draws vancomycin, making it explicitly selective to vancomycin. Yeah. So basically, we polymerize onto a gold chip, and then under a UV lamp with vancomycin and peptide in our monomer solution. Then, after the polymerization is complete, we elute off the vancomycin, leaving these pockets. And then vancomycin sees the peptide, sees the shape, and says, "This is cozy," and then stays there. And then that's what we measure through here. So, vancomycin concentration filling those pockets that we created in the MIP disrupts the current that's flowed through. And then we detect this change in the frequency that occurs, that'll correlate to the concentration of vancomycin in our device. We created this device with our users in mind. It's small, lightweight, and battery powered, perfect for transportation by hand or on a standard nurse's cart for bedside readings. It also transmits the via Bluetooth the data to cell phones, so that way someone could be in the lab ready with the dosage while the nurse is still with the patient. That way we have less people running back and forth doing different things. Also, the device itself is very intuitive with the touchscreen and button for the nurses. But perhaps most importantly, we require a small sample size, so it makes this device ideal for treatment in infants and small children. So yeah, is that all kind of makes sense? Yeah. Okay. Well, that's what we have. Any questions?
Are there any questions?
You take the samples of your blood sample?
We hope to do some further research to move to whole blood, but right now it would be plasma. It's an electrolytic solution, so yeah, so it would complete the circuit. Anything else?
Well, then I have a question because you explained. I'm going to use the microphone.
Oh,
because
we're doing everything for Sense Digital, and otherwise no one can hear me. So you're showing the techniques and how your sensor works, but how were your results yesterday?
Our results had a correlation, so I'm really proud of that. They weren't kind of random, so I was very proud and very pleased with the way our team did yesterday.
Oh, good. Thanks.
Yeah.
Great.
That's the same question of what was your plan afterwards?
So definitely thinking about getting our MIP even more specific, more consistent polymer films, and possibly whole blood down the line. But yeah, there's a lot of potential with this device. I'm really excited about it, and I hope y'all are too.
Okay, thank you. Any other questions? Okay, then this is it for.
Awesome. Thank you.
Thank you very much. And yeah, we're still on schedule, so I'm going to get the next team for you. I hope you'll still stay to watch. Is that Spain? Great. Yes, it is digital.sensus.org. Doet de website het? Yeah. Okay, then I would like to give the floor to you. Good luck.
Where I have to...
Just the next one. Yeah.
Okay. Hi everyone, I'm Ramon. I'm from UScience State Barcelona, and we came from Spain. And we came from 2 different universities, and we have studied biomedical engineering and mechanical engineering. These are the members of our team. This is a representation of our final device that will be a kind of point of care device that will have a screen that will show you the concentration of vancomycin, will be portable, and will require a small amount of sample. This is how it works. First, we have electrodes coated before measuring the sample. We will introduce a reference sample. We will introduce a reference vancomycin that will be attached and blocked to the electrode. Then a mixture of the sample and an antibody will be introduced to the sensor and will measure by impedance. If we want a more accurate measure, we can add a second antibody and measure again, but this will take more time. In Spain, we have problem that the isolated hospitals that are away from the city don't have labs to perform this test, and they have to send the samples to in a lab that will be 2 hours away from them. This is an expense of money that we can solve with our device and help these small hospitals that are away from big cities. Our device have the originality of this mixer that will be the most important thing of the device, that will mix the sample with the antibody. This is a is developed by our team, this mixer, and it's like diffusion by these different sizes of the channel, and use microfluidics, and it's measured by impedance. We are using a competitive ELISA to measure that. It's a type of test that usually use optics, but we are using impedance to measure it, and we reduce the time needed to perform this test. The most positive aspects of our device are that it requires a small sample, it's portable, and we could use it to decentralize the assays performed of this test and help the small hospitals to be able to do this test and don't have to send the samples. Thank you for your attention.
Are there any questions from the public? And if there are, so could you please repeat that in the microphone so that we can online also hear the questions?
Yeah.
Is it electrochemical impedance spectroscopy or just impedance?
Impedance electroscopy, just. Yeah. There are any other questions? Yeah.
Very nice, thank you. Are you considering continuing with the work?
We didn't talk about it yet, but maybe if the others are interested, we can continue with the device. Well,
Any other questions, maybe?
yeah. Well, they are not as good as expected. Yeah. Why? Because when we were testing the device, we were doing it with more time, and we were short of time, and also we were testing with the second antibody too, and we only could test it with one antibody.
Any other questions, maybe? Okay, then I have one, if I may.
So your results weren't what you expected, but is there another prize you would like or hope to win this afternoon? Is there one favorite?
Maybe the market prize or the public prize. I hope you vote for us, and if you want to come to our stand to have more information, please.
Okay,
Thank you. Thank you very much. And then for this stage, we have the final presentation of the teams, which is Team Sweden. And I see they're already there. And after that, the award ceremony of the high school projects will also be here. You can come. The floor is yours. And good luck with your presentation. If you would like that one.
Oh, I get to
Yes.
talk so much.
Yeah.
Good luck. Hi. Hello. Is this how this works? How did this? Cool. Hi. We are UVS. Is this on? Yeah. Okay. Really close. All right. Hi. We are UVS from Uppsala University in Sweden. Uppsala Vancomycin Sensor. We are a team of 8 students with 1 coach and 1 supervisor. We come from a diverse background: Sweden, Germany, Japan, Syria, Algeria, Canada, Mexico, and the US. We also come from many different disciplines: engineering, microfluidics, chemistry, biology, machine learning, and forensics. We have spent the last 10 months trying to develop a biosensor that is low cost, easy to use, and with quick response times. Here we have our input device on our input tube on the device, and you can easily load the blood sample here, and it will be flowing through, mixing with our fluorescent custom in-house made fluorescent vancomycin, which will then flow through the T sensor shaped channel shown here. And in the T sensor shaped channel, the antibody protein will be allowed to bind with our vancomycin. At the end of the channel, there will be binding with the custom-made fluorescent vancomycin and the normal in blood vancomycin. And we will detect it through our optical system, excitation through LEDs. The LEDs will excite the fluorophore on our molecule and give us a signal shown on the graph, which will be picked up by our USB microscope or in-house light microscope in the clinical lab. From here, we have a complex computational program that will process the results and give you a concentration readout of vancomycin in the blood. We hope that through our device, it will make it easier for medical providers to have quick read times and quick results and easy use with low cost. So it will improve the results by decreasing the strain on healthcare providers with read times in less than 5 minutes. And our device is also cheap at only 38 cents per test, so that the healthcare providers can run as many tests as necessary. And our device also takes up very little space, as it is no bigger than a basketball. So you can carry it around the hospital or just keep it in the lab. So we have optimized the system for with our customized fluorescent vancomycin and unique pump flow-through system and advanced image detection. And we made it also transportable, so it's easy to use. And the best part of our device is that it's low cost and fast read times. So it's these factors make our sensor optimal for widespread clinical use, and we think you will agree. Our system is unique in its use of pump and flow-through diffusion technology, especially when paired with our strong fluorescent vancomycin and brilliant LED system. And our team is committed to providing patient-oriented, innovative, and efficient solutions for your healthcare needs. So we look forward to bringing our device to the market and hope you will choose UVS too. Thank you.
Are there any questions from the public? Yes, I'll give you the microphone.
Thank you. You have mentioned that your test will be 38 cents, but how much a doctor should spend on the device by itself, and how much you spent on parts? I mean, when you build up this.
For us, the device, well, the most expensive part has been the antibody, but you do not really need that much. Since we've developed the vancomycin ourselves, the fluorescent vancomycin ourselves, then it really reduced the cost, and we pretty much built the whole assembly except the microscope, which we assumed the hospital would have already since it's developed for hospitals at this time. So keeping that in mind, we calculated that it would be 38 cents per test, but to purchase the device initially, probably no more than 20 euros. Yeah, it's cheap. It's low cost. Any other questions?
We would like everything to be to the microphone.
Now your device is based on slightly complicated microfluidics. Is there any clogging issues if you're going to work with real blood or other complex samples?
Due to the addition of the blood to our input tube, it dilutes the blood. So we haven't had issues with clogging, although we haven't used pure blood. We've been using blood plasma. So we haven't actually tested on real blood. So we're not sure about the actual, if that would cause clogging. So yeah, you're welcome.
Any other questions? So, if I may.
We've been asking the other teams if they would continue with their project after the competition. What about your team?
We've been discussing continuing with our development, actually. We think we have a good system, and with a little more work, we think it could be even better. So we think we could continue. We haven't all committed to it yet, but we're still talking about it. So yeah.
Well, if there are no more questions, then thank you very much. And another round of applause.
Thank you.
Yes, thank you very much. Can I have the clicker? Yes, thank you. So that were all the team presentations. And within a few minutes, the award ceremony of the high school project will be here. But we have a short break.
Today, as well as those who are joining us live on the digital SensUs. I'd like to let you know, the audience, that these teams have been working their butts off. Yesterday, I went to the market during the testing session, and it was incredible. There was so much buzz and excitement. People were talking science. People were like running around with racks and tubes and passing samples on to people. It was amazing in like a chaotic, exciting, chaotic sort of way. I really enjoyed it. The energy was really great. And there was free candy. That was great. But the best part of it for me was really to see how your innovative devices were working and how you explained them to me, really. That was super engaging. And I thank you for that. So I got to say, I'm completely in awe with what you've all done in the last 9 months. Great work. So I just really want you to give yourselves a round of applause for all the good work you've done so far. So firstly, who am I? My name is Amy and I'm your MC for today. I'm a research scientist here based in Eindhoven University of Technology. And you might have heard from my accent, but I'm actually from New Zealand. That's New Zealand back there. Kia ora. Kia ora, indeed, as we say down south. And I say I'm from New Zealand. That is also where I did my PhD. And to be honest with you, it was real tough because the mountains were just so distracting. So I decided to move here to do my postdoc in the Netherlands. And also, well, here they have really good dairy products as well. I love your cheese and your windmills. But also, most importantly, I love your science. Here I'm doing research on artificial cells. And if you're curious, it's pretty cool. Just give me a chat after this, because right now, it's not about me. It's about SensUs. It's about you. And one of the most favorite things that I have about this competition is how it's such a grassroots university student-driven initiative. Like, it's all done by all these young people in the front, and I really love that. And now it is my complete pleasure to introduce the chair of SensUs, and this is Elena Russian. She's going to come up on stage and give you some information about this competition.
Thanks. So, can everybody hear me? Yes. So, hello everybody, and welcome to the finals of SensUs 2018. I'm Elina Rutten, and I am the chair of the SensUs organization, so I represent the group of students who organize SensUs. And we are really happy to see all of you here today at the third edition of the SensUs student competition. So this year there are 13 universities participating in SensUs, and they are coming from North America, Africa, Asia, and Europe. So the aim of SensUs is to stimulate innovation and education in the field of biosensing on a worldwide scale. So actually we are really proud that all teams are coming from all over the world. So over the past 10 months, these teams have worked very hard to develop biosensors in their own university. And now they are here in Eindhoven to present their results. But besides demonstrating and pitching their results, we also had some additional activities, and I do not want to spare them. So during the opening on Wednesday, the teams arrived in Eindhoven, and we had a drink in the city center, and we got to know each other, and together we kicked off the SensUs event of 2018. So on Thursday, we had a Meet the Partner event. And here it was all about the interaction between our partners and the participating students. So it was a very inspiring day, and the partners gave workshops to our students. And yesterday, the teams have tested their biosensors. I see somebody laughing because she's on a picture. Nice. So what did teams actually measure this year? Well, the team of SensUs changes every year. In 2016, the teams measured creatinine, which is a key biomarker for kidney failure. Last year, in 2017, the teams measured a protein hormone, which is a biomarker for heart failure. And this year, the teams are measuring an important antibiotic drug called vancomycin, which is used a lot on the intensive care. So antibiotics are drugs that help to stop bacterial infections. And antibiotic drugs are widely used in our society, and these have already saved millions of lives. However, overuse of antibiotics is a serious global threat, as it causes bacteria to become resistant to the antibiotic. And becoming affected by such a resistant antibiotica can happen to anyone of every age in every country. And therefore, antibiotics should be given only when the patient really needs them. And when they are given, they should be given in the exact right dose, perfectly tuned to the needs of the individual patient. However, the difficulty is that every patient is different. So the dose should be adapted to the person and to his or her condition, which can fluctuate over time. And at every moment in time, the dose should be high enough to kill the bacteria, but low enough not to be harmful for the patient. And this is where biosensing can help, because a biosensor can measure the exact concentration of an antibiotic, and in this way, we can immediately adapt the dose of the drug. And this is exactly the aim of SensUs 2018. The teams have developed biosensors to measure an important antibiotic drug called vancomycin.
And the teams have worked very hard. It's very extremely difficult and demanding to make such a prototype. So we all should have a lot of respect for the teams and admire their accomplishments. So as I already said, yesterday the teams have tested their sensors during the testing event. And today they will give you a 1-minute pitch during this opening ceremony to tell you all about their innovation. Later on, they're also on the market and they are waiting there to answer all of your questions. So at the end of this day, we will find out who the winners are of SensUs 2018 during the award ceremony. And the awards will be granted by a jury. They're over here. And they are consisting of professors, healthcare professionals, and industry representatives. So they will hand out awards in 4 different categories. So first we have the Analytical Performance Award. And this award is all about the measurement, accuracy, speed, and sample volume of the biosensor. Then we have the Creativity Award, and this is all about the technological novelty of the sensor. Then the Translational Potential Award is all about the plans of the teams to bring their prototype to a real product that can be used in our society. And last but not least, we have the Public Inspiration Award. And this award is actually about you. Who inspires you the most? The public. So you can cast your votes via SensUs Digital, which is a platform that we developed, so you can vote for your favorite teams. You can see their biosensor results. You can ask questions to the teams, and even more. So please visit SensUs Digital and cast your votes. And if you have any questions regarding voting or any other issues, please do not hesitate to ask one of the organization members. You can recognize us by our white blouses. They're over here. So I now would like to close to wish you a very inspiring day today. And now Amy will walk you through the program of the rest of the day. Thank you.
Right, thanks a lot, Selina. Right now, could I please ask the 1-minute pitch people to come up on stage and sit at your respective stools? Thank you. So the program behind me, as you can see, we have the opening, which is what we're doing now, and also the 1-minute pitches, which is what they will be doing soon. And shortly, we will have the market, which will contain lots of different stalls and activities, one of which will be all of these teams giving a 3-minute pitch. In parallel, there is a stage 1 and 2. And if you have burning questions after their pitches, they also have posters down in the room below on the left there. And there you can also ask them more questions about their work. I believe iGEM will also have a stall, as well as our 3 sponsors, Realitech, TPP, and Exicon will be there. So go check them out and say hi. Just really quickly, I would like to highlight the high school project. They will also be giving a pitch there today at the marketplace. They have also done a project on biosensors, and they also have a poster. This is the 2nd edition of this little event, and I really would encourage you all to go forth and support these next generation innovators. So without further ado, I would like to start the 1-minute pitches. I can see you're all very excited here on stage, ready to go. When I click the slide and your country name comes up, please come up here into this box and give your pitch, and I'll also give you the clicker. Okay? All right, are you ready? So I also have a timer, by the way, and please keep it to 1 minute. If not, a strange, yes, there will also be a microphone. There will be a strange dolphin sound that will play if you exceed 1 minute. Please, let's not do that. So, the first university to come up for a pitch is actually Sweden. Just kidding.
Hey, we are UVS, Uppsala vancomycin sensor from Uppsala University. We come from a diverse background in both origin and discipline. Implementing this diversity, we have used hard work and strong team building to build a unique biosensor that will help with patients and providers to make their lives easier. We present a unique biosensor that uses an established system in flow-through technology, diffusion chip technology. It's simple. You just add your blood sample to the device, let it run through the chip, and get a readout of vancomycin concentration in the blood. It's fast, easy to use, and cheap. At 38 cents per test and 5 minutes to read, you can get fast results with little effort and low cost. It's a great system. We would love to talk with you more about it. So please come to our stand and check out our 3-minute pitch. Thank you very much.
You can pass it to Canada.
No.
No.
Well, I mean.
Well, I will.
Okay.
Yeah.
Okay. Hi, I'm Elizabeth, representing BioSensIm, the Canadian team from the University of Montreal. We're a group of 10 students with a very wide variety of backgrounds. Our biggest strength throughout this competition was our creativity, our resourcefulness, but especially our unstoppable perseverance. Despite the many, many, many challenges we had to overcome, we're very proud of the prototype we developed. So our detector actually broke the night before the competition, so we had to change our game plan overnight. The lab-on-a-chip bioassay that you see here remains the same, but we came up with a new and improved detection method using our cell phone camera. And we then had to reprogram our data processing for our phone application, but now it works really well. And funnily enough, it's even better than our first plan. But most of all, we're really excited to be here for the first time and participate in biosensing innovation. So please come see our 3-minute pitch and our stand this afternoon. Thank you very much.
Hello, my name is Dina, and I'm representing the Danish SensUs team, Detectors. So, as you just heard, antibiotic resistance is a global threat, and as vancomycin is a last resort drug, it's really important that we can monitor it precisely. For this purpose, we have developed a sensor that is fast, accurate, and easy to handle. Now you may ask, why is our sensor this good? Well, every single component has been specially custom-made for the purpose of detecting vancomycin. So we have done sensor chip fabrication in our clean room at DTU. Furthermore, our biochemistry have been specially constructed by biological entities, and our electronics have been customized to be fast, keeping the usability in mind. So please come to our pitch later and hear more about our technology, and drop by our stand, see our PCB where we have added the Danish national anthem. Thank you.
Do this? No. Okay, go.
Hi everyone, I'm Patrick from Team iXense, and we are from the RWTH in Aachen, better known as Aachen, La Chapelle, and Akis Granites. And as I only have a minute, I'm going to jump directly into the essentials. We make use of vancomycin antibodies and the polypyrometrics, which works like concrete to foster the antibodies. Even though it is a novel technology, only standard processes are involved, such as chronoamperometry, which is basically just a voltage step over a few seconds. To measure at least the vancomycin, we are using impedance spectroscopy, which leads to a fast response time and also low power consumption, which might be interesting for handheld devices. Last but not least, our projected design, which you can see on the bottom right, left, offers flexible materials and also differential readout to reduce the noise. I'm looking forward to see you at our stand to tell you more about everything. And yeah, that's it.
Thank you. Can you please stand there? Thanks.
Good afternoon. I'm representing the AUC team. So what you see behind me are the 6 most important attributes of our biosensor. I'm not going to go over each one of them because I'm assuming you can all read, of course. What I am going to talk about is the purpose of life. So we are all here to help make the world a better place. And us humans have this inherent feature to help the people around us. And everyone should seek to share their knowledge and share their time to build something as amazing as this biosensor. And I think my team and I have successfully translated that purpose into our device. And we wouldn't have achieved that amazing work if we didn't have an amazing dynamic. And for the past year, I've had the honor to work with them, and it was an amazing experience. So we would be really honored for you to come and see our biosensor and look at it with more detail. Thank you so much.
Thanks.
Hello, everyone. Okay, fine. This is loud. I am Mark from the Van Gogh team, and we're here to present our beautiful team. That's us at the University of Glasgow. So we have developed an original idea that came from us and is an MRI-looking ELISA-based magnetic system that would allow us to not only measure vancomycin, but as we go optimizing it, measure anything that can be detected with antibodies. So we can move into all kinds of healthcare and labs. So that is ours. We actually added lots of different components in case of the needs of different consumers. And it's basically, you have the nice sample over there, which is the measurement, and then like a few other features, as well as a magnetic wash. We also included the TMR sensor, which is the latest technology on the market. And we really want to invite all of you to come, and we'll tell you all about it. Thank you very much.
Here we go. The Netherlands. Do you need this? No.
So I'm sure everyone here is have been in surgery or have been in the hospital after surgery or have visited friends or family there. The one question that we will ask the doctor in that situation is, when can I go home? My name is Lotte van Dassler and I represent TEST from the university here in Eindhoven. And with our biosensor, the answer to that question is a lot sooner. With the biosensor of TEST, it is possible to measure the concentration of vancomycin within 3 minutes with only a droplet of blood. So, well, how do we do this? The ingredients are a laser, a magnetic field, and nanoparticles. And we have made it all fit into this small portable device that is ideal for the home care setting. TEST would love to show all of you our biosensor. So come by our stand and visit our pitch, and we will learn you how our biosensor works. Thank you so much.
So hello everyone, we are Sense Imperial and we represent Imperial College London at this competition. Basically for the past 9 weeks, we've been working on the design of a detection system for vancomycin. The current solution, basically the current approach to this problem is based upon clinical lab analyzers. So they need to be performed inside labs, and they need to be they are basically like really bulky and expensive devices. Therefore, we need like portable devices which can be used at the patient bedside. And our solution is a combination of a lateral flow assay and a smartphone app. Our biosensor, therefore, is really accurate and quick and really cost effective and easy to use and accessible to everyone, either with technical technical skills or like non-technical people. Thank you for your attention, and please come to our page 148, stage 1. Thank you.
Spain.
Hi everyone, my name is Andrea and I am representing the EU Science Tech Barcelona team. You might all know my country because of the football, paella, siesta. But apart from that, we are a very big country in Europe. We have more than 46 million of inhabitants and more than 500,000 kilometers square. Because of this, our country is very centralized, and big cities play a key role in general and public healthcare. Our biosensor brings a solution to this by approaching technology to remote areas. The sensor consists of a mixture, as you can see in the picture, which was developed by our team. And it uses impedance spectroscopy for measure vancomycin levels in blood. Please, if you want to know more about it, visit our stand and come to our team page. Thank you.
Hi everyone, welcome to VancoSense. We're the team from Belgium. We care about patients. We pursue better healthcare. VancoSense is a user-friendly device. We use slide system and touch screen for easy operation and fast measurement. It is a perfect dosing advisor. After measuring the vancomycin, our sensor will give you instruction on the dosing. More importantly, it is not just a sensor for vancomycin, but a generalized platform for all the antibiotic detection. Are you curious? Are you interested? Our better future embraces for your involvement and support. Thank you.
Play the video now. Do you want to? Yeah, okay, this one.
Okay, good afternoon, everyone. Are you tired of the traditional ways to test chemicals? How do you usually describe them? I think heavy, expensive, probably toxic, and most importantly, complicated. So now it's time to change. Using our biosensor, you just need a computer, a mobile phone, and some test strips. You can get the results precisely and conveniently without harmful regions. In the meantime, its portability allows you to use it anywhere, anytime. Its low cost leads to an affordable price. And what's more, remember, we are TrueSense from Zhejiang University. Hope you to vote for us. Thank you.
The greatest achievements in science does not belong to those willing to stay within the realm of what is known to be possible. No, the future of science belongs to those who have the bravery to attempt that which has never been done before. SensNC has accepted this challenge. Through the creation of our handheld biosensor, we've explored the combination of molecularly imprinted polymers with a high-affinity peptide, giving rise to a chemical lock-and-key type system, which we hope will be the key to selective and accurate detection of biomolecules in human plasma. So, I invite you to come, sense, and see the future of electrochemical biosensing.
Wow. Okay, please, let's be serious. Just for one sec, because we talk about antibiotic resistance and it's a sad topic. And the saddest part of it is that in Switzerland, treatments get longer and people are deprived of fondue cheese for more than 2 weeks sometimes. And in Switzerland, we had to address this issue. That's why with SensUs, we wanted to create a device that the doctors and nurses could directly use themselves. And that's why we created Heidi. Do you know Heidi? It's a small little girl in the Swiss mountain taking care of her grandfather. And our device is exactly that, a cute Swiss thing that takes care of others. It sits by the doctor, it measures the blood of the patients and then tells the doctor how to adapt the dose. And you know how it works? Well, come at our pitch. We are the first team to pitch, unless the other is swap again. And also come at our booth and we will introduce ID directly to you. Thank you very much.
All right, thank you, everybody. I hope you've all presented now. Otherwise, no, just kidding. Thanks a lot, guys. And I'm guessing all of you out there are super excited to see their 3-minute pitches now. But before I let you go, please be back in here at 3 o'clock sharp so that we can continue on with our program with Shauna Butler's talk. And for now, all I have to say is let the markets begin. Is it good? All right, everybody. Hello. Hello, everyone. Welcome back. Welcome back. I hope you had a great time during the market session just now. Now, I'd officially like to say that voting is closed, and thank you for everyone who participated in that. And you guys did really well during the 3-minute speeches. Well done. Now you can all just relax and enjoy the keynote speaker, who is Shauna Butler. She is a nurse economist with a love for technology. She's originally American, but I recently found out today that she's also actually a Kiwi. And by that, I mean not the flightless bird or the fruit, but a New Zealander. Cool, right? Yeah, but now Shauna is living here in the Netherlands as a entrepreneur in residence at the University of Radboud, and I would like you all to give her a very warm welcome.
So kia ora, welcome, and I have to tell you, you guys are awesome, absolutely awesome. I so enjoyed your pitches. And I have to tell you, I have some divided loyalties going on there for a couple of reasons. One, I have a daughter at the University of Glasgow, so Tigers. She rose, so I'm expecting that you're going to be out there at 4 o'clock in the morning when it's freezing cold and you're cheering her on. And of course, I'm from the US, so well done you. I'm not sure why New Zealand's not showing up and representing, because heaven knows they've got a lot of great technology happening there. But more importantly, what I see is diverse ideas. I see diverse faces, but I see everybody cooperating around something that's really important. And our colleague here from Egypt, who basically pointed out that we're actually here to talk about the meaning of life. So thank you for that. So I have been swimming in technology conversation since I was 8, literally. My mom was the secretary for the dean of a very large, at a university where he was the dean for engineering, science, and technology. She was a single parent. She needed childcare. And the university had this swimming program that ran after school. So every single day, and it was every single day after school, I would go hit the pool. And then when I finished, I'd walk up to her office. And I spent all of this time surrounded by these wonderful engineering conversations. They also, the PhD students, noticed that my hair was wet. And like, oh, she's a swimmer. So anytime they had to do anything that was looking at water, so if they needed to do propeller design or human performance, they would take this cute little 8-year-old, hook her up with a bunch of sensors, and take her into the pool. And so I spent a lot of time around competitions that were on the university. And this is one of my favorite ones. It's the concrete canoe. And seeing which of these teams who could compete to get the canoe to float made out of concrete. The interesting thing is that wasn't the hardest part of the competition. The hardest part was getting the canoe down into the pool deck. So, and I bring that up because a lot of times what we're thinking about in solving these interesting problems is that sometimes it's not the technology, it's everything else around it. It's the cultural acceptance, it's the adoption of it. So from poolside technology conversations, I graduated into this place, the bedside, as a nurse. And I spent an awful lot of time taking care of people and their families at times when things were not really happy for them. And I don't know how many of you have had to work with vancomycin and take care of people with it, but the problem that you're solving is very real. And when we get it wrong, really bad things happen. And talking to a 65-year-old woman who unfortunately has had had a toxic dose and can no longer hear you, can't hear her grandchildren. These things matter. And so it's really important to get those things right. So I spent a lot of time in the clinical environment, and I also got to do international medical transports, running all over the globe and seeing care delivered in a lot of different ways and a lot of different places. And an infection is an infection is an infection. But how we experience it is quite different depending on the resources that we have available to us. So I ended up at this really interesting place called Singularity University. It's based out in Silicon Valley. And what we focus on are helping to inspire, educate, and empower leaders to use technologies that have exponential curves to solve humanity's grand challenges. Our guiding question is, how do you solve the problem for 1 billion people in under 10 years. And we're looking at solving and addressing humanity's grand challenges. We specifically, when you think about when I'm talking about these different technologies, you've probably heard a lot of them. Oh, my goodness, that slide didn't go so well. Anyway, computational networks, a lot of sensors, augmented intelligence, sometimes people call it augmented reality, virtual reality, robotics. And it's not any one of those technologies. What's interesting is that each one of those, they've gone on these development curves that are really slow, kind of imperceptible. And then all of a sudden, they just take off. And what happens as far as broad-based acceptance is the enablement tools that we use. How are we thinking about how do we engage groups of people to gain insights that we wouldn't necessarily have right within an institution? So all of the maker spaces that are out there, crowdsourcing, how are we going to fund something using crowdfunding? So it's actually the interesting piece of how do we bring those technologies together with the crowd enablement forums to actually create some interesting breakthroughs. And we have a lot of incremental change and improvement. But what we're really looking for at Singularity University, the thing that we focus on is that moonshot. How do we go in a great big huge leap and create a breakthrough in something that we've never been able to do before? So in particular, on the healthcare side, I helped to create a program and a conference and a community called Exponential Medicine. And what we like to think about it is like Disneyland for clever optimists. We know that there are some really big problems out there and some challenges that need to be solved. But what we're looking for are those people who are willing to take these technologies and play with them and experiment with them and find their use cases. And I got to work with my colleague here, Daniel Kraft. And the interesting piece about this photo is that we are in a virtual surgery. And so there's a patient in one part of the world, we're over in another, and a consulting surgeon is in another continent. And combined all of those things together, we're actually able to do things that we weren't able to do before. And one of the things that we do at the conference is we introduce people to the technology. So when we do our group photo, we do it by drone. And right there in the middle is a huge contingent from the Netherlands. And they come over every year. One of the things that we find is that group of people who are there with us, they are the group of people who have been told all their lives, that's a crazy idea. It will never work. Maybe the best compliment they ever get was, good luck with that. And our founder, Peter Diamandis, he likes to say, it's always a crazy idea right up into the day it works. And one of the pieces when we think about these ideas and how important they are to find them, oftentimes we're going and looking in the exact same places or the predictable places of where we think we might find good ideas. The only way to have a good idea is to have a lot of ideas. And as leaders, one of the things that we need to think about doing is how do we find those people who might have some thoughts about this, but we're not hearing from them. How do we actually find them? And one of the things that we focus on at Singularity University and what I get really excited about are competitions. And one of the things that I love about competitions is that they surface and create a culture of challenging the status quo and looking for original ideas and inviting new people in. There are three groups of people that, there are a lot of groups of people that we're not actively including, and I want to name three of them. The first of them, particularly in the healthcare space, we don't engage the people who are the experts in the condition, better known as patients. I challenge each one of their teams to think about this. How many of you included a patient on your team to help you think about it or to test it? And we're not doing that really with anything. The second group that we're really leaving out is who spends the greatest amount of time with patients? Who's there at the beginning and end of every clinical interaction? Who coordinates all of their care? It's the nurses. And if you go across the globe, you won't find any nurses included in those agendas. And the third group of people that we're not including are students. We're not including the people who are earliest in their career, who have unconstrained thinking, reckless thinking, actually, wild imaginations. And they're doing it at a time when they really have the skill set and without somebody telling them about a regulation or a HIPAA compliance or some type of thing that says, oh, that will never possibly work. When we don't bring in that beginner's mindset, there is so much that we're not capturing. And that is one of the reasons why competitions just get me so excited. I want to share a clip with you of a competition that the story is actually featured around somebody that we've gotten to know pretty well and solving a big, audacious problem.
The winner in the category of medicine and health sciences, the crown
making it to ISA. That's like the big thing. You kind of have that status of being in like the group.
I would say that a lot of people are jealous of me.
On deadlines, I'm awful. I wait until the deadline to start working.
I listen to trap music and classical music.
Pass it up. Blast it up full volume.
I actually don't listen to classical music that much. I just listen to mostly trap.
You're not going to cure cancer, you're going to prevent cancer.
Yes.
If you're there just to win the prize, you're missing the point of science fair.
You enter into this new kind of world I didn't even know kind of existed.
It's one of the best weeks of my life. Like every time I go there.
Ela tem sonho realmente de sair, de crescer. E eu acredito que se eles venham lá, as portas talvez vão se abrir.
I'm going to be so proud when one of my kids win a Nobel Prize, because they will.
It's so simple.
Finalists from 78 countries, regions, and territories around the world.
You can think of it as the Olympics of science fair.
We ain't going nowhere to the end of the world. Ladies and gentlemen, introducing the most impressive. I plan on shaking the planet until I'm convalescent. If I could just achieve, and not just me, but anybody else is going to create what only I can. So simple. Simple as 1, 2, 3.
Winning will change your life in ways that you don't even comprehend.
Welcome to Los Angeles.
Today's like the judging day. So we're going to get judged for what, like 6 hours today? I don't know.
So I guess you guys can relate to what's going on there. The young man at the end, he's from West Virginia and had some really interesting ideas about how we can be thinking about cancer. And didn't win. Actually, he was recruited by a firm out in Silicon Valley. And I'm not even sure he finished graduating from high school. The young woman in there, I'm trying to remember her name, I'm blanking on it, but she's from Nebraska. She went to a high school where what they really value is football, and she couldn't find a science advisor to support her on that. Her advisor for that was the football coach. And again, some really interesting things, but I share that with you from the standpoint of students are just undervalued in their ability to really catalyze some new thinking. So well done, good on you, and I am so glad to see you guys are here. So another piece that I wanted to share a little bit about at Singularity University, one of the things that we focus on is a mindset change. So the way we're wired is to think about things linearly and locally. We understand very clearly how to do one-to-one or one on a community. But with all of the things that are changing, and particularly sensors, and we bring in sensors and data, we're going to a very different community in a very different world that's highly networked, highly connected, so that we can do things one to many or one to millions into the masses. So what does exponential actually feel like? So if I were to tell you that I want you to take, to go 30 meters, if I asked you when you were a third of the way there, you'd be able to tell me and you'd have a really good prediction. But if I asked you to take 30 linear steps, we would go 26 times around the globe. So it's very, very hard to wrap your head around what an exponential pace would look like. 20 years ago, and most of you probably weren't even born 20 years ago, we had all of these devices that we had on our desktops or that we had in our cars or that we used. They were very physical materials, and we worked with them in very different ways. But within the advent, a lot of the technologies, things growing exponentially, and they're getting faster and smaller and cheaper, and they're in your pocket, they're in your wrist, they're actually inside of your body. We not only do things differently, but we have all these new companies, and we meet our fundamental needs in completely different ways with completely different companies, many of whom did not even exist a decade ago. So it's created this thing, what we refer to now as the digital health economy, and that's a big piece of what you guys are participating in helping us to develop. We now, when you think about that traditional medical bag that somebody would carry with them to go and take care of somebody, it looks completely different. It's actually in a phone or it's on a small chip. And it changes, like even in surgery, our tools, they're dramatically changing. This is probably what it's going to look like. So, and again, part of the thing that I want to share is that while we focus on sensors or we focus on technology, it's not any one technology. It's actually what happens when we combine all of these things and we have the convergence of them. And particularly in sensors, it's just like any other thing on Moore's laws. They're getting faster, smarter, cheaper, smaller, and we can use them in all sorts of different ways. And when you compare it and you pair that with our communications technology right now, we're at 4G, and just look at how GPS, how well that works. But imagine when we go to 5G and we're able to move faster, more reliably, and we have that much more data. And we've gone from the Internet of Things to the Internet of Health Things. And with all of these sensors, we now have the Internet of Human Things. And what that does fundamentally is just a completely different shift in how we think about how we take care of ourselves. For the most part, what we've been in is this place that's very reactive. We wait until somebody's sick and then we intervene. And what we're able to do now with all of this, particularly within a sensing environment, is that we're not only able to be proactive, but we're actually able to be predictive so that we can optimize. And if you take a look at how we've gone with care, we've moved it from a place where we waited for something to happen, and now it's just ambient and it's sensing and it's telling us, and it dramatically shifts where we do it, how long it takes for us to get information, and healthcare becomes something that's on demand. It also creates some new diseases and some new phobias that I'm sure that the World Health Organization is going to be helping us to be thinking about. And the other part that's really interesting is, and you take a look at our health outcomes, because we've been talking about medical care. What we really need to be thinking about is our health experience and our outcomes. And if you break down what somebody's life experience and what their health experience looks like, you can see from this very clearly that it's more about our lifestyle and our choices and our environment. If we have better information about each one of those things, we can dramatically change what that health outcome and what that health experience is like. And when we think about what these sustainable development goals are, they start tying into how we're actually going to be able to achieve them. And getting to this place of when we talk about precision medicine, because right now we have imprecise medicine. Too much of what we do, it's done for populations. It doesn't talk anything about what gender you are, what race you are, what environment you live in. And too many times medications or devices or anything that we're giving, they're actually not helping very many people. In some places, they're actually doing harm. So let's think about what this environment looks like with all of these cool sensors. And this is kind of the fun, cool stuff that I get to play with in working with a bunch of different companies and technologies and inventors and catalysts. Is that when we start putting sensors in the environment, what does life actually start to look like? What are some of the things that we can do? Things that we've had to be in usually some type of prescribed care environment to be able to check all of these different parameters that help us to understand our function. We're able to understand what our heart rate's doing. We can look at this somewhere remotely. There are patches out there that people can wear that I can actually hold my phone, it's sensing, and it can do a 12-lead EKG. Imagine what this looks like for at the very beginning in conception, for us to be able to reach people that that are basically hard to reach, and more importantly, hardly reached. And it's getting the first years, the first 100 and first 1,000 days of life started off in a much more safe way. Think about those kids that maybe they're born a little bit early and we want to keep them monitored. What does it look like when we've got devices that can actually give us some better indications about what a child's hydration status looks like? What is it they're absorbing and what is it they're not absorbing? Sometimes we can understand maybe a little bit too much, maybe too much information on that. Have we gone a little bit too far when we're trying to analyze every single thing that a child is doing? Think about when we have people staying at home in their own environments and we're a little bit worried about them. What are the ways that we can use sensors to tell us a little bit more about their circulation, about their gait, about all of their exhaust, if they're complying to smoking cessation, if they are looking at trying to manage alcoholism or some other type of a substance? How are we using it to detect other types of exhaust, like perspiration? What type of sensors and what are we picking up from all of those types of chemical responses? This is another place that nurses spend an awful lot of time, is looking at, our ins and outs. And we've got new technologies for that. Thinking about keeping people safe and preventing them from falling or injuring themselves, maximizing their performance, helping them to manage some type of a tremor or some type of a movement disorder, all sorts of devices that are not only sensing, but they're also supportive. This is another form of a really interesting disease that we're starting to develop. We're seeing a lot more patterns with this problem. Well, we now have devices that can sense what your posture is, and not only sense it, but then remind us what's going on so that we're training ourselves. We have a set of trainables. What about those sensors that start to see when we are at risk, and maybe they can help to prevent something? There's a company here in the Netherlands actually who has one of these that you can wear as an undergarment, so nobody can actually see that you're wearing it. And it does an amazing job of reducing the problems with falls. We talk a lot sometimes about how we're thinking about how we're going to manage illness and how we're going to restore that. But what about those group of super athletes? What happens when we start giving them sensing devices and we combine that with virtual reality? What are the new types of human performance records that we might be able to change? So at the end of the day, when you think about all of those sensors, it's a really interesting challenge. What are the questions around the ethics of all of this? Where's that data going? Who's keeping an eye on that? Who's sensing whether or not there's been somebody tapping into your data? So it solves a lot of challenges, and it addresses things that we weren't able to do. And at the same time, it also creates some new business opportunities. So the other part of that is that it's interesting to sense each one of those, but what we're really looking for is an integration. It's not so much that I want to know what my blood pressure is at every moment or what my hydration is or any of those other pieces. What I want to know is the integration. Am I okay? How well am I doing today versus yesterday? And what are my targets for the coming days? So when we have that data and we have the insights, then it actually starts to change what we're able to do and the recommendations that we're able to make. Sensing, being able to figure out, are they taking their medication? Did they actually pick it up from the pharmacy? Are they taking it? Are they taking it correctly? How often? So it helps us to understand when we're dosing it right. Thinking about the other piece oftentimes is that we need emotional coaching. We need encouragement. So when you've got all those sensors tied into things, we can start offering different health benefits. Think about how many times you guys live off your phone using an app to figure out where you're going to go out to eat, all of the different ways that we use apps. Well, more and more and more, I don't know if you've got any idea, but in the last month, there were 350,000 health apps that you could download from the Google Play Store or from Apple. There are that many. And what's interesting is patients are coming in all the time and asking, how do I manage my feeling of isolation? I'm trying to quit smoking, I'm trying to lose weight, and they're looking for something. Most healthcare providers, they don't know either. They're looking for all of that. And so there's a group that we're partnering with at NHS who's using another technology, using AI, to start looking at safety and efficacy and cultural relevancy to figure out which apps we should be recommending. And the other part why it's really important to think about those apps, and particularly with behavioral change, we have a more intimate relationship with our phones and our screens and our devices oftentimes than we do with the people around us. So we're able to gather data that's honest and real, and maps to the reality that the reality that we have versus the reality that we wish we were living. It gives us opportunities for being able to diagnose, to coach, to triage. Think about those things that we're wearing that can give us some indication about how we're doing and maybe encourage us to do a little bit better. The other part that I mentioned was it's not just one particular device. It's not just sensing. It's convergent of each one of these technologies. So what happens when we take sensors and we start putting them in our transportation and in our deployment? How many of you have seen about the autonomous vehicles and seeing where we're actually starting to put fleets together? And when that starts to change, how we're able to deploy the resources that we need. Imagine that you've got a sensor that not only tells a condition, but then also that there's a need of an individual and also a set of equipment, and being able to deploy that. This is one that I think is really fun. We all need our coffee in the morning. But you laugh at all of this, but the way IBM is looking at this is that they're tying it to all of the apps that you might have on your phone and telling you about how much you slept last night, taking a look at how long it took you to wake up. Are you moving slowly? Are you kind of feeling tired? And being able to sense, maybe you need a cup of coffee to jolt you awake, to be at your very best. They're also looking at that technology of maybe somebody's had too much alcohol to consume. Maybe we need to make sure that the drone doesn't deliver that, and thinking about underage alcohol consumption. So there are lots and lots of ways where we combine that sensor with another technology with a health goal and seeing what we're coming up with. The other thing that I get really excited about is all these maker spaces. And maker spaces, because of where we've gone with sensing technology and where we've gone with the form factor, we're actually able to take it right to the side of where it needs to be delivered at that moment in time. And so there are maker spaces that are popping up in hospitals or in the community or in libraries where people are coming together with their specific condition, with their healthcare provider, and they're actually making that device that is working for them. Within Maker Nurse, one of the things that's really fun is that once they come up with a solution, they upload it and open source it. So if you figured out something for a 3-year-old that maybe has a malformation and can't feed themselves very well, if you figured out a special spoon for that, there's probably several 3-year-olds around the world who need that exact solution. And then somebody can go to their library, download it, and 3D print it. And it's happening, it's all over the world. And it's interesting to see it's not just in the resource-rich areas. If anything, it's happening more in the resource-poor areas. So one of the things that I want to kind of leave you with when we think about where we're going with this, where technology can take us, and particularly when we think about the sensors, the data, the insights, moving into clinical interaction and making clinical decisions. Right now, when you think about healthcare, and it really is healthcare, there are 4 different streams there. And we think about that predominantly it's physician-led, that it's very transactional, that it's very siloed, and it's about medical care. But when we think about the technology and what we're able to do, what we're moving toward is something that becomes self-enabled, human-centered, integrated, and much more broadly about our health and well-being. And it gives us the opportunity to design profoundly better health experiences and outcomes. So I wanted to share, that concept of when somebody says that you can't do something, I want you to think of this.
She packed my bags last night, pre-flight. 0 hour, 9 a.m. And I'm gonna be high as a kite by then. It's lonely out in space. Such a timeless flight. And I think it's gonna be a long, long time till touchdown brings me round again to find I'm not the man they think I am at home. Oh, no, no, no. I'm a rocket man, burning out of you out where we belong. And I think it's gonna be a long, long time. And I think it's gonna be a long, long time. And I think it's gonna be a long, long time.
So with that, I will remind you, do not wait for an invitation. Proceed until apprehended. Thanks.
Thank you, Shauna, for that really inspiring talk. I love all the amazing things you told us about how technology can impact your health as well as your life. And now I would like to thank you with a gift and a handshake.
Thank you.
Thanks a lot. Here we go. Some gifts for you.
All right. Thank you so much.
Yeah.
I'll do this.
Yes.
All right. No, Hwangi.
Cheers.
Hwangi.
Wow. That's Kiwi. Yeah. All right. Now, teams, this is the moment that you've all been waiting for. I think the judges have deliberated, and we're now ready to begin the awards ceremony. All right. So for this, can I please ask the jury members and the chairs to come up on stage? This year, there were a lot of juries. In fact, they were split into 2 groups, and both of the groups were led by, hold on, well, can I please have 2 of you here, by Rogier Hofstaken and Kees Verdaan. And this is Menno, and I will introduce you in a moment. Menno, can you please sit down? Thanks a lot. All right. So just a quick introduction. Rogier Hofstaken here is a general practitioner with heaps of experience in point-of-care testing. And he was involved in SensUs in the past, and he's back here this year as the chair of the Translational Potential Award, the chair of that jury. And Kees here is a medical microbiologist. He's now working as a consultant for PAM Laboratories down in Veldhoven. And today he is the chair of the Creativity Award. And I believe you both now have a few words to say about the jury and the awards themselves. And the floor is both, wait a minute, the floor is both yours, but how can we hear you if we don't give you microphones? Here we go.
So, thanks a lot for the introduction. I think I'm glad you asked about the jury process, because as you have seen, a lot of my members of the jury didn't make it today because they're all exhausted and tired and probably admitted to a hospital, flushed by vancomycin because of possible infections. So we had a really hard time judging, and it's because you did such a great job. That's the basic reason. And next to that, it was a thrill to judge the whole process, the team, and to speak to all of you, because I think, wow, I almost get emotional when I talk about this project and this event. It's really amazing what you all achieve. So, compliments. Yeah.
Now, just really quickly, Kees, at the beginning here, you, as a microbiologist, you looked at these awards and you made some remarks about them, right?
Yes.
I was wondering if you could maybe take us through what they are.
They look like Petri dishes in a bit of strange color, but this is what we normally work with. And to tell you a little bit about it, what you can see on this, for instance, this prize, somebody is going to get it, I don't know who, but we'll see soon. You see bacteria growing, and that's because normally a bacteria can divide itself in 30 minutes, and if you wait a day, you have a colony. And a colony is nothing more than a heap of bacteria. And that's still the basis of microbiology. It's very slow. So your biosensors are very fast. You have to do it within 5 minutes, but this takes a day. To have an identification takes you another hour. That's quite fast for microbiology. But if you want to have a good antibiotic resistance pattern, it costs you a day. If it's simple, and if it's very difficult, it costs you perhaps a week to find out what's really going on. So these are all Petri dishes in different colors. We don't have them in our laboratory. I like the orange color, of course, because it reminds me of the Netherlands. And well, I'm going to hand it over to the winner of the Creativity Award. Yeah. And to tell you a little bit about the jury, I didn't know them before yesterday. So I came here, I didn't know them. And I've now know that they are all very knowledgeable, very experienced, far more than I am, because I'm just an end user of the products you've made. And I'm really amazed by the work you've done and by the solutions you came up with. I'm really, proud that I can be here and give a prize to one of the winners. But I think you're all winners. So in the end, don't blame yourself if you're not getting the prize from me, because I think you're all winners.
Yeah.
And one thing that's important to tell, just short, is that we had quite a discussion about who should be the winner. And in the end, we came back to the concept. What we did is we filled in papers, and they were added, and sort of the mean was coming out, and that the order that was found there is still the ranking that we followed. So we had a discussion.
Yeah.
Quite hard, but it's still
but
there.
We'll come on to that in a moment, because now let's crack on with the awards. So first, Rogier, can you please come back here? And he'll be handing out the first award for analytical performance. And now, I hear this was purely judged based on algorithm, right?
That's right, and it was not my job, actually, but they give you a hard time this year if it comes to accuracy and delivering your test results at the right moment. So it was really a difficult job.
Yeah, and as a jury member overall for the whole competition, how did you feel about it all?
Well, like I said, we had little time to really enjoy, because we really made a tough job, and we did our best, and you deserve that. So that's what we did. Yeah. And we had a great time. So
I think I've delayed you all enough, and you're sitting on the edge of your seats. So I think it's time for the award of the second prize, runner-up.
So, runner-up. I think there were two teams that were quite close to each other at the end, and front runners compared to the other teams. So the runner-up, number 2, for the Analytical Performance Award is Van Gogh, University of Glasgow.
All of you. Please come and stand here. Go on, stand near the front, guys. Everybody. Woo. That's cool. In the square, if possible. Thank you. And a little smile there. Congratulations, everybody. Nice work. All right. I took this off you, but you may have it back.
So we come to the winner. Let's do it.
Come on now, everybody. Let's do it.
It's a team. The winner of the Analytical Performance Award, SensUs 2018, is SensUs, Switzerland.
Stand in the square. Everybody in the square, please, in the square. Get in the square, please. Go on, come up to the front. Yeah. Please, one of you hold this. Nice work, everybody. Congratulations, everyone. Really nice work. All right. All right. So now I would like Kees to come and to present the Creativity Award, I guess.
Before I start telling you who is the runner-up, it's good to tell you that there were 3 teams that finished very close to each other, the top 3. And although there's no third prize, I think it's good to tell you who is the third, who ended third, and that was London University. So. So, the runner-up for a Creativity Award, which we like very much, is the University of Lausanne, Switzerland.
You know where to stand. Near the front. Thanks. Who wants to hold this time?
And now the first prize, Creativity.
Come on, guys.
There we go. It's for Van Gogh, Glasgow.
Thank you very much. Thank you. Can you please hold this? Yeah, thanks. Congratulations. Congratulations, everyone. Great work. And now for the Translational Potential Award, I would like to introduce Menno Koch, who's been sitting here very patiently for us. Yeah. And you need a mic indeed. Here you go. And please tell us a little bit about the award and how important is it, do you think?
I think, if you ask me, it's the most important one. Because in the end, who's going to be the real winner? We don't know today. We won't know today because we see lots of talented people. You know, any of these 13 teams for me is a winner because they all have a remarkable achievement. They worked as a team for 9 months. They didn't have a single fight, I checked. So they should find some way to actually go on with this because that would be a real waste if we had 13 absolutely fantastic prototypes that didn't go beyond that stage. And of course, the Translational Award is exactly about that. Getting it applied in real life, selling it, having doctors use it, having home workers use it, having maybe patients themselves use it. We have 3 teams that actually focused on that. Because that's, of course, in the end is the winner. The winner takes it to the world. So this is why I think, in a sense, the Translational Award may be the most important one. It was also the most difficult one because you have to learn about healthcare systems. You have to talk to doctors who usually don't have time for you. So they will make 5 or 10 minutes and give you the quick answers. And then you have to push and push and push to get the real answers. And maybe you shouldn't be talking about the doctors. We just heard about that. You should have talked to the nurses. Maybe talk to the hospital managers because they are going to buy. They're about the money. And learn about what is my business model? What am I going to propose to them? Why is it so interesting? A lot of you came up with the time factor. And of course, that is a very important one. It's actually crucial in this technology. But also the time factor will play no role if the technology sits at your place and the hospital doesn't have it. So this award very clearly shows how well teams actually interacted with the outside world. So I can't let you wait any longer to find out which 2 teams were strongest in that aspect. And it's a surprise for me as well, so I'm going to read it very slowly. Aha. A new kid on the block. No, sorry. It's Lausanne.
Yeah, thanks. Here you go. Just really quickly, just really quickly, I would like to ask, how do you feel? One of you, talk to me. 3 awards. Tell me, how do you feel right now?
It's surreal. I don't know I was really not expecting that. It's so like, it means so much to have all the work that you have put like validated by those juries of experts and by you guys. So thank you so much.
You thoroughly deserve it. Nice work. Oh, thank you.
For the real thing, and it's in gold, you see, and they don't get to hold the envelope because we keep it here. Yeah, real gold envelope. So I promise you a new kid on the block, so we'll see whether there's a new kid on the block for the real winner. And here we go. And it's not going to be a movie star because we won't redo that mistake. It is the team from Leuven.
Near the front. It's a lot of you. Let's gather. Yeah, just in the box. Maybe some rows. Thank you. Can one of you please hold this? Congratulations. Congratulations, everybody. Nice work. Wow. All right. And now the last and final category of award, I should say. I would like to ask Rohir back to present the Public Inspiration Award. And I give you a microphone. And Rohir was particularly excited to be presenting this award. So I'd like him to maybe say a few words about it.
Well, the organization asked me, do you want 500,000 euros or present the Public Inspiration Award? And of course, I chose for the latter, because that's the most important award, Mano, for sure, because it's about you, about our patients, our future patients. It's about getting this thing going on. Despite all those industries which are active right now, we need you and the patients speaking out loudly that they want better care. And there's room for better care. And you are important to provide that. So I think this is for sure the most important award. There are more than 3,500 votes. There were more, but some people tried to get their vote done 2 or 3 times. But there was a really good organization here, so they skipped all those votes. So for sure, 3,500 regular votes.
Wow.
And yeah, wow. Again, a very exciting competition. All the teams got a lot of votes, and 2 were the best.
Here you go.
So the runner-up, number 2. I don't know exactly how many votes, but it was really close again, is for the team Test Eindhoven.
Up the front, please. Thanks. Here you go. You get to hold this. Whoops, sorry.
Then the team with the most votes. Is it the country with the most people or not? most fans, relatives, whatever.
All right.
Well,
Because
for
this
sure.
is the last one, everybody, give yourselves the biggest drum roll ever.
Last year they were a little bit late at the event, but this year they win this trophy, the American University of Cairo.
Thank you. Up the front door. Come. Oh, well done, everybody who won. And also those who didn't win, congratulations for being here and for doing a great job the last few days. Yeah, do it. Applaud yourselves. No. Stay. Please stay. All right. Can I please, please stay on stage. And now I would like to thank, on behalf of the committee, you guys for helping us out for the yesterday and today. Your input has been valuable. And for this, I think there are a few treats for you before you go. So maybe if you walk this way, we can get them. Yeah. But yes, up on stage. It's great. Thanks a lot. Without you, there is... Come this way a bit. For the photo. Yeah, you need, yeah, very nice. All right, quick photograph for... All right, thanks a lot. Oh. All right, team. I reckon, well, this is it from me. It's been a complete pleasure being your MC for today. And I guess now I'd just like to hand the floor over back to Elena, who will give you some closing words.
I will thank you. No, you come back to me. Yeah, you come back. Yeah, because of course, first of all, we want to thank you for being our Masters of Ceremonies today. Because it was the first time for you like this, being on stage.
It was.
But you did great.
Thanks.
And we enjoyed your energy and your enthusiasm.
Thanks a
Give
lot.
me a hand. So we have a present for you.
Thank you. Cheers. Thanks a lot.
Thank you.
Yeah.
So there are still a few more things that I would like to say. So first of all, congratulations to the winning teams. You did an amazing job, really. And also to the other teams, because it was very impressive what you all shown us here. A nice example is the team of Canada. Their sensor was stuck somewhere in Europe. And their sensor arrived at Thursday night, and we run to a building, and they were there for the entire night working on their sensor. And also their detector broke, and they figured that out, and they did an amazing job. So really, all the teams. Yeah. So, but this event would not have been possible if it wasn't for many people. So I would like to thank the auditorium for the lighting and the sound. And the Mute Zone and MK2 for shooting all our film material. Bart van Overbeke for making all our beautiful pictures. All the volunteers that helped us this week. Tuincentrum Brekelmans for sponsoring our flowers. And last but not least, our partners, because they helped us the entire year. So give them a hand. So now there's a quite large group that I would like to thank, and that's the organization. So please stand up. Maybe come here. Yeah, come. Come on stage, yeah. Yeah. So we did not plan this, but a little bit more in front. So actually we did quite an amazing job all together, and I wanted to say that I'm extremely proud of all of you. And yeah, it was quite an unforgettable experience to organize this Sensus edition together. So give them a big hand. Yeah. And then there is one more special person that I would like to thank, and that is the founder of Sensus, Menno Prince. Yeah. So Menno, yeah, we have to be in the book. So Menno has been our guide for some of us 1 year, but for me already 2 years. And I can say that he's a very good guide, and he coaches us in both our professional and our personal skills. So we are very grateful for that. And I also would like to say congratulations, because this is the 3rd edition of Sensus. And look at all the people that are here, what were there yesterday, all the participating students, all the jury members. Actually, there are so many people involved in Sensus right now, and we should be very proud of that, especially you. So thank you for that, and congratulations.
Dank je wel.
Oh.
Ja, dank je.
So now Sensus 2018 has almost come to an end, and now Menno will give you a short introduction into Sensus 2019.
Okay, first of all, I'd like to thank Elina and all the other Sensus organizations members for these kind words. It's an honor to be their coach, but they very much inspire me also, because I see their energy, I see their developments, and they introduce lots and lots of new ideas. For example, we had the Meet the Partners event on Thursday, we had the Sensus Startups on Friday. Those are all their ideas, and we try them out, we learn from it, and then year after year, it's an iterative process. We develop those ideas into something that becomes really big. And so I'm very happy to have the honor to work with you. So let's give them a hand. So Sensus is an annual process, and every year we have a different theme. Elina already explained, it was kidney failure in the first year, then it was heart failure, today is infectious disease. And what about next year? And I want you to make a guess. I'll give you a few clues, and then you think about it. So this is a disease, and it has a prevalence of nearly 1%. So you all probably have somebody in your environment who has this disease. It's a chronic disease, and it starts typically at the age between 20 and 40. I think medical people already know which disease it is. But let me continue. It's a disease that involves pain, typically at the joints. Now, speak with your neighbors, and what is it? Yes. Can you say it louder? Yes, rheumatism. Yes. Well done. Rheumatism, also called rheumatoid arthritis, that's the most well-known name. It's an autoimmune disease, and unfortunately, it cannot be cured. But it can be managed. If you get the right medication, then the inflammation goes down and also the pain is relieved. And a very important new class of drugs in this domain are the so-called biopharmaceuticals, and they're also called biological drugs. These are protein-like molecules, and they are now really advancing, and they're being used in the field of cancer, oncology, and they're being used in autoimmune diseases like rheumatism.
And the marker for next year will be etanercept. And that's one of those biopharmaceuticals, and it blocks one of the signaling molecules of the inflammatory system. And in that way, it reduces inflammation. Now, there are a couple of problems with this treatment. And one of them is it's very expensive. And the second one is that dosing is important, just as vancomycin is very important in the case of infectious disease. Because if people get too much of the drug, it harms their health. For example, they may very easily catch infections because the immune system is being shut down or is being lowered. If they get too little, it doesn't resolve the pain and doesn't resolve the inflammation. So dosing is very important. And then, of course, biosensors can help, because then easily patients and doctors can take a drop of blood, can measure the drug concentration in the blood, and then adapt the dosing. Now this close, oh, wait. We have a movie.
I'm Miranda, I'm 33 years old, and since 4 years I have rheumatic disease. My disease affects the daily activities in my life. Mostly the pain is in my wrists and hands, and so you can notice it with small things, simple things like groceries. I would like a tool to help me to determine the right dose of medication, so that patients like me can get on with their regular life.
Okay, so that's it. This is what we're going to work on the coming year, and I hope that the present teams are going to help the new teams to do the right things, not fall into pitfalls, start early enough working with blood plasma, start early enough consulting doctors. So I wish you lots of success in helping the other teams and making a great Sensus 2019 next year. Thank you, everybody. Wil jij nog even zeggen van de networking drink? The networking drink?
Oh. So thank you all for being here today. We really hope that you enjoyed Sensus 2018. And now we would like to invite you to come to the networking drink, with what will be just outside of the auditorium. So thank you, and we hope to see you next year. And can the winning team stay here for a photo? The winning teams on the stage for a photo.
We monitor what we eat, how long we sleep, and how many steps we take. In an increasingly digitized world, we are becoming active participants in our own health. The next logical step is to monitor what is inside of our body, using biosensors, small devices that are capable of tracking down and detecting specific molecules in our body. We can better monitor our health and detect diseases that we cannot see externally. Every now and then, people become ill. Some people get better soon, but many have to face a long recovery period. People who have been discharged from the hospital are bound to require frequent checkups. A biosensor could enable those patients to perform these measurements by themselves in the comfort of their own home. With the development of new and better biosensors, we can improve the quality of life. This is where Sensus comes in. Sensus is the annual student competition on biosensors for health. Student teams from all over the world come together to compete with their newly developed biosensors. In this way, Sensus takes innovation and education on biosensors to a whole new level.
Eindhoven Startup Alliance is creating a symbiotic relationship between high-tech startups and large-scale corporations in the Eindhoven Brainport region. The founders of the Eindhoven Startup Alliance, ASML, Philips, BOM, High-Tech Campus, ABN AMRO, EY, NTS Group, and HVG are on a mission to accelerate at least 100 high-tech hardware companies by 2020 and produce at least 20 that join a high-growth curve. becoming the next original equipment manufacturers, the new industry giants, creating thousands of new jobs. The vehicle to achieve its mission is High-Tech XL, a framework of programs designed to drive startup growth from ideation to scaling up, supporting promising startup and scale-up teams to bring their technologies to market. Together, the Eindhoven Startup Alliance will dramatically boost the impact of innovation in high-tech hardware throughout the world.
Regardless if your project is still proof of concept or a fully commercialized product, maybe a microneedle patch, multiplex well played.
Hi, I'm Andrew Baker Campbell. I work as a consultant at the Technology Partnership, a company that develops new products and new technologies for our clients around the world. When a client pays for our help, they get a team of people who can both come up with new ideas and then take those ideas all the way to a finished product. What attracted me to TTP was a chance to be innovative, but also to have an impact on the real world. TTP has turned out to be a great environment to invent, offering a chance to act like an entrepreneur, but with the support of smart and experienced colleagues. Working at TTP has given me a chance to work with lots of different industries, from products you would sell in a DIY shop to parts for satellites. My days are pretty varied too. One day I might be working in the lab in the morning and then talking to a Far East manufacturer in the afternoon. Another day I might be traveling to meet a new client overseas and getting to see their high-tech factory. At the moment, one of my developments is a new kind of gas sensor. It's my hope that this sensor will drop the cost of monitoring patients' breathing in hospitals, improving care here and also in the developing world. So how do you get a job like this? A true passion for technology is a must, as are great analytical problem-solving skills. A strong physics or engineering degree from a top university is a minimum requirement. We're looking for people who follow trends in tech and can have a fun conversation about them. Maybe people who've been involved in technology clubs at universities, spent their summer at an interesting company, or have even been involved in a startup. If you want to know more, visit www.iop.org/careers, and good luck.
At Micronet, we develop and produce state-of-the-art devices for microfluidics and MEMS applications for distribution all over the world. Our products include a broad range of chips in various sizes, as well as complete wafers. We have the capabilities and processes in place to develop tailored solutions from design to manufacturing. For example, a microfluidic chip in a cartridge generates accurate quantitative results within minutes. You innovate constantly to stay on top of the market. Micronet can provide you with crucial core technology parts for your products. For an optimal solution, we offer you a selection of just about any material or combination of materials: glass, polymers, silicon, or even hybrid combinations of these or other materials. Together with you, our expert engineers devise a solution that meets your needs, taking functionality, scalability, and cost into consideration. Our flexible processes occur in our ISO-certified production facilities in the Netherlands and Germany. For example, we can include surface functionalization, such as spotting picoliter amounts of biomolecules. Quality control and assurance measurements, such as statistical process control and traceability procedures, are embedded according to ISO 9001 and ISO 13458 directives. After release, the product is ready for distribution all over the world. You can start working with a device right away upon delivery and obtain reliable test results. At Micronet, we provide innovative lab-on-a-chip and MEMS solutions that help our customers improve your products and research, contributing to the quality of life. From idea to design to large-scale production, at Micronet, we're ready to accept your challenge. Like to know more about Micronet's creative product development and manufacturing capabilities? Visit micronet.com and discover what we can do for you.
So yeah, that's very nice to be here in Eindhoven to discover this new city with everyone.